Let's look at this example. And you are given x is a bracket 1 t plus t minus sin t. So x is a bracket t minus sin t. Y is a bracket 1 minus cosine t. And you are asked to find dy dx. We are going to use this result to find dy dx because x and y are given in terms of t. We have parametric equations. So you find dy dt, you divide by dx dt. So you differentiate this pair of parametric equation. A is a constant. A is a constant. So to find dx dt, A you just keep differentiate t is 1. Differentiate sin t is cosine t. Yeah? So which means it's just 1 minus cosine t times A. Then dy dt is just a bracket. Differentiate 1 is 0. Differentiate cosine is negative sine t. So minus give you plus. So it just give you a sine t. So actually this part is actually you take dy dt divided by dx dt. Dy dt is a sine t, so the numerator is sine t. Yeah? Then the denominator is a bracket 1 minus cosine t. And you can cancel a. Yeah? You can cancel a and a from the numerator and denominator. If the question did not ask you to simplify, you can give this as an answer. That means you can just give dy dx as sine t over 1 minus cosine t. You can give this as an answer. In some questions, you might be asked to show dy dx is cotangent t over 2. So let's say the question asks you to show dy dx is cotangent t over 2. Then you cannot stop here. So you have to use trivial identity to change it and simplify to cosine t over 2. Okay, so which means we will start from here and then try to show that sine t over 1 minus cosine t will be same as cotangent t over 2. And with that you need the half angle formula. You know that you have sine 2a, right, is 2 sine a cosine a. So we take this as sine 2 times box equal to 2 sine box cosine box. Okay, and if you look at the question, you want to change it to t over 2. From t, you change it to t over 2. That means t you write it as 2 bracket t over 2. So t you write it as t times t over 2. Okay, so let me write it here. So in this case, 2 bracket t over 2. Okay, so you do that to show what you want. It means if you look at sine t, you should take this as is sine 2 times then t over 2. So which means you fill in inside the box, you fill in t over 2. So it's actually 2 sine box and cosine box. So we just need to fill in t over 2 here, t over 2 here. So each box you fill in the same expression. So if you fill in t over 2 into the boxes, from the formula sine 2a is 2 sine a cosine a, you just replace all the a term by boxes. And then because you want sine t, so it's 2 times t over 2. That means TO2 go inside the boxes. So with that, it tells you sine T is 2 sine T over 2 cosine T over 2. And that's how you end up with the numerator. The sine T, right? The sine T, you can change it to 2 sine T over 2 cosine T over 2. So that's how we have this. Next, we'll be looking at the expression 1 minus cosine T. So we'll be looking at 1 minus cosine T. Why is it same as 2 sine squared T over 2? And to do that, right, again, we look at trigo formula. We look at trigo formula. For cosine 2a, right, for cosine 2a, there are 3 formulas. It's actually cosine square a minus sine square a is 2 cosine square a minus 1 minus 2 sine square a. And we will be looking at the third one. So cosine 2a is 1 minus 2 sine square a. And this is take it as is cosine 2 times box equal to 1 minus 2 sine square box. And then if you fill in T over 2, if you fill in T over 2, then it tells you cosine 2 times T over 2 is T, is 1 minus 2 sine square T over 2. So you'll be using this. Okay, so 1 minus cosine T will be same as 1 minus bracket. So you go back and see what's the answer is actually 1 minus 2 sine square T. Cosine T is 1 minus 2 sine square T. So it's actually 1 minus 2 sine square T. So it's actually 1 minus 2 sine square T over 2. Is 1 minus 2 sine square T over 2. Okay, so if you expand out, it will be 1 minus 1 plus 2 sine square T over 2. 1 and 1 cancel, so we left with 2 sine squared T over 2. And that's how you end up with this 2 sine squared T over 2. So 1 minus cosine T is 2 sine squared T over 2. And then you can do cancellation. 2 and 2 cancel. Sine squared T, right? When you have sine squared T over 2, is actually sine T over 2 times another sine T over 2. So which means you can cancel them. It means you can cancel sine T over 2 and sine T over 2. You can cancel with one of them. If you cancel one of them, it's like cancel the square. So that means what you're left with is cosine T over 2 over sine, right? You recall the definition. Cotangent theta is cosine theta over sine theta. So cosine T over 2 divided by sine T over 2 give you cotangent T over 2. So with that you get what? You get the simplest answer, cotangent T over 2. You'll find that one thing about simplifying is in the later few slides we'll be looking at how to find d2y dx squared. And you'll find to find d2y dx squared, if you start from here, you start with dy dx equal to sine t over 1 minus cosine t, you need to differentiate dy dx again. So you need to differentiate this fraction. You need quotient rule. But if you simplify dy dx to cotangent t over 2, then it's just a simple term. It's easy to differentiate further. Then that's another reason why we will simplify. If the question asks for d2 by dx squared, if you simplify it, later you will find that to find d2 by dx squared is much easier.